code for life.
Chaucer has asked that I put together a summary of how DNA encodes the blueprint for making a human being.
Well, let's use your DNA for the subject. I would love to know how your DNA works.
I had already taken a clipping of your hair to use, but I guess I could use that to make an effigy doll to stick pins into. But here we go. Jeeves, would you help me out, please?
The human body is a truly amazing machine. "650 muscles, including a heart that can beat more than 3 billion times. 206 bones. More than 1,000 miles of airways in the lungs. All coordinated by billions of electrical circuits in the form of nerve cells. Over 100 trillion cells that somehow know how to grow and develop according to a central plan that is encoded in the heart of every cell inside an amazing molecule called DNA. Today we are living in an amazing era when science is accomplishing something we never would have believed that we could do. In fact, it has been said that this is the ultimate imaginable thing, to look at our instruction book and understand what it is telling us.
Wow! That little strand with the tiny drops on it is an actual page from that instruction book?
Yes, it is part of the blueprint for making a human being, and we can actually read it. There is no reason to expect that any creature made from tiny specks of inanimate matter should be able to develop the ability to understand itself.
But we have, and we do. And as far as we know, we are the only creatures that can do this, that can ponder our place in the universe.
And there it is, right there on the screen. We can look at a section of that tiny strand and know that it tells us what color eyes we might have, or how tall we are going to be.
Wow!
This compilation is the human genome. 3 billion letters long, this is the instruction set for making a human being. But it is more than that too. It is a history of where we come from and who our relatives are. It contains the edits and the changes that have taken place during our journey for billions of years. The human genome is an amazing compendium, and as we are able to read it, a story is unfolding, written in a code of 4 letters that tells us who we really are. Some of the things we are finding make sense only in retrospect. 50% of the genes in a cauliflower are also in us. We may think we are unrelated to a cauliflower, but a little over 1 billion years ago we share a common ancestor. This is only one of the stories we can read in the Book of the Genome. Along with us, cauliflowers contain all the chemical machinery for replicating DNA, all the machinery of controlling the structure and the functioning of cells, all the machinery for making tissues, and between cauliflowers and us, all that is necessary for life. As we examine the genomes of creatures closer and closer to our branch on the Tree of Life, we find their genomes are increasingly similar to our own. We may share 50% of a vegetable's genome, and perhaps 75% of a reptile's genome, a plotline that dates back about 300 million years ago. And 85% with a mouse, a chapter from 75 million years ago. And if we look at our closest living relatives, like the gorilla and the chimpanzee, you will find that we share 98% of our DNA, a page from just 6 or 7 million years ago. The genomes of all humans are 99% the same. All the people in the world, regardless of height, weight, color, eyes, hair, and other features, are all different in only one part in 100 in their DNA. All the differences and similarities in our mitochondrial DNA prove that we all share a mother who lived in East Africa some 150,000 years ago.
I don't quite get it, Diana. What do you mean that our genome tells us where we came from? And what's that stuff about reptiles and 300 million years ago?
Well, let's look at you and your relatives, Kevin. You share more genes with your siblings than you do with your first cousins. And you share more genes with your first cousins than with your second cousins. Each step takes you back one more generation into your ancestry and makes your genes a little more different. With a little work on your genome, we can estimate how long ago you and someone else shared an ancestor.
Yes, that's pretty easy to understand.
Similarly, by comparing the genomes of two different creatures, we can be pretty certain how long ago they shared a common ancestor, a creature that isn't one or the other, but a creature from which they both derived.